Hello students, and you are welcome back to Solve Your Physics Past Question class. Today we'll be focusing on the concept of general gas law, as we'll be solving questions in relation to pressure or Gay-Lussac's law and general gas law. So the first question I have here with me from the past question 2011 through to 2020, it says a gas at pressure of 2 atmospheric pressure or 2 atmosphere and 27 degrees Celsius is heated to 127 degrees Celsius while keeping the volume constant. What will be the new pressure of the gas? So from our question, you can see that we'll be using Gay-Lussac's law, which have to do with pressure and temperature since the volume is constant. Then using Gay-Lussac's law, we state that P1 all over T1 equals to P2 all over T2. So from our question, we're given the first pressure, we're given the first temperature, we're given the second temperature, but we're not given the second pressure, which is what we're looking for. So we plug in our values into this as we convert our temperature to Kelvin, from Celsius to Kelvin. So then we have 2 all divided by 27 plus 273 Kelvin equals to P2, which is the second pressure or the new pressure, all divided by 127 degrees Celsius plus 273 Kelvin. So when we make P2, which is the second or the new pressure, as the subject of formula, as we cross multiply, we then have P2 equals to 2 times into bracket 127 plus 273 Kelvin, all divided by 27 plus 273 Kelvin. So our final pressure, or the new pressure, will be equals to 3.7 atmospheric pressure. So the next question I have here with me says the pressure of a gas changes from 1.5 atmospheric at 27 degrees Celsius to 2.4 atmosphere at 87 degrees Celsius. What was the initial pressure of the gas at 27 degrees Celsius? Using the same Gay-Lussac's law, we then have P1 all over T1 equals to P2 all over T2. So we're told to find the initial pressure, which is P1. So we then have P1 all over 27 plus 273 equals to P2, which is now 2.4 as given from our question, all divided by 87 plus 273. So when we cross multiply, so we then have P1 equals to 87 plus 273 Kelvin, all divided by 2.4 times 27 plus 273 Kelvin. So our P1, which is our final answer, will be equals to 0.95 atmosphere. The third question we'll be solving in today's class is a gas occupies a volume of 4 liters at 27 degrees Celsius and 1 atmospheric pressure. If the temperature is increased to 127 degrees Celsius while maintaining constant volume, what will be the new pressure? So from our question, we can see that we are still going to be using our Gay-Lussac's law as our tool to solve this question, as the right tool to solve this question. So using our Gay-Lussac's law, which states that P1 all over T1 equals to P2 all over T2. So here we're told to find the new pressure, which is the P2. By plugging in our values, we then have 1 divided by 27 plus 273 Kelvin equals to P2, all divided by 127 plus 273 Kelvin. So by making P2 the subject of formula, after cross multiplying, we then have P2 equals to 1 times into bracket 127 plus 273, all divided by 27 plus 273 Kelvin. So when we plug in these values together and multiply them and divide through, then our final pressure, or the new pressure, will be equals to 2.2 atmosphere. The next question we have here, which is the fourth question for today's class, says a gas initially has a volume of 3 liters at 25 degrees Celsius and 1 atmosphere pressure. If the temperature is increased to 75 degrees Celsius while keeping the pressure constant, what will be the new volume of the gas? From our question, we can see that this is quite different from what we've been solving before. So here we're dealing with volume and temperature, provided that the pressure is constant. So now we'll be using our Charles law. So that means we'll be using V1 all over T1 equals to V2 all over T2. So as we're told to find the new volume, having given the initial volume, so that which is V2. So V1 would then be 3 all divided by plugging in our values into our, our formula. We then have 3 divided by 25 plus 273 Kelvin equals to V2 all divided by 75 plus 273 Kelvin. So by cross multiplying and making V2, or which is the second volume, the subject of formula, we then have 3 times into bracket 75 plus 273 close bracket all divided by 25 plus 273. So by adding these and dividing through, we then have our new volume to be 3.6 liters. Then the final question we have here for today's class, it says describe Boyle's law and provide a practical example where it can be applied. So we know that Boyle's law states that at constant temperature, or as temperature is remain constant, the pressure of a given mass of a gas is inversely proportional to its volume. So take for example, when compressing air in a bicycle pump, the volume of the air decreases as the pressure increases, which illustrates the Boyle's law. So this is where we're going to be stopping for today's class. And we hope with what we have learned in today's class, we've been able to better your understanding on the concept of the general gas law. As we solve more questions in our next class, join us again where we're going to solve more questions in relation to general gas law, Charles law, Boyle's law, and Gay-Lussac's law to better your understanding on any external examination questions that may come your way. Thank you again and bye for now.